everyone, welcome back to our second video for modeling with inequalities. Here's a couple of vocabulary reminders. So instead of just using all the operations, we are also going to be using greater than or equal to, less than or equal to, instead of just an equal sign. That is the difference between an equation and an inequality. So this slide you can go back to for some helpful reminders. For Diego's birthday, he received an $80 gift card to the store. Movies cost $8 and books cost $4. The linear inequality below describes the number of movies and books Diego can buy without spending more than the amount of his gift card. He wants to buy combinations of books and movies, but he doesn't want to spend more than his gift card. So if you notice, not more than, we're using this less than or equal to inequality symbol. So if Diego buys 5 movies and 10 books, how much money will he have left on his gift card? So if we go ahead and take a look, we have 5 movies on the x-axis and 10 books on the y-axis. We have a point here. Because this line represents the different combinations that he can buy, all of the shaded region, anything on the line, because it's a solid line, means he would spend $80 exactly. Anything in yellow means it would be less than $80. So because that combination, if you think about it, 8 times 5 is 40, and 4 times 10 is 40, so 40 plus 40 is $80, so he's going to have $0 left on his gift card. If Diego wants movies and no books, how many movies can he afford to buy? So he has $80, so if we just look at the x-axis for movies, I can buy 10 movies and 0 books and I'll spend $80, no more. Give 2 different combinations for what Diego can buy. So there's many different answer choices for this. For example, I can choose anything on the line or in the shaded solution area. So I can buy 5 movies and 5 books, or he could buy 2 movies and 12 books. There are multiple answers for this. Can Diego buy 6 movies and 12 books without spending more than on his gift card? So let's check it out. If we go to 6 movies and 12 books, we have this point, and that is outside of our solution area, so that's no. Taking another look, the total fees for the high school play are $250. Tickets to the play cost $5 for students and $10 for non-students. Write a linear inequality that describes the number of student and non-student tickets that need to be sold for the drama class to be able to pay for the fees. So if you notice, we have X is number of student tickets, Y is non-student tickets, so like adults, senior citizen, children, things like that. So we have 5X plus 10Y, and we use this greater than or equal to $250 because we want to be able to pay the fees. If we make more than $250 selling tickets, that's wonderful. But if not, we need to sell at least $250. Finish graphing the inequality by shading the correct side of the boundary line. So the line shows $250 exactly, all the different combinations of tickets for students and non-students that we can sell to get exactly $250. But if we want more than or equal to, I need to shade above the line. So this is my solution area. If the drama club sells 14 student tickets and 12 non-student tickets, will they be able to pay the fees? Why or why not? Well, if we take a look at 14 students and 12 non-students, we have a point here. If you look, it's outside of the shaded region. So no, 14, 12 is not in the shaded region. What does the point 40-10 mean in context of this problem? So if we go to 40 and 10, If we look on the x-axis, that's number of student tickets. The y-axis is number of non-student tickets. So this means 40 student tickets are sold. And 10 non-student tickets. Taking a look at one more, a sandwich shop sells sandwiches for $5 each and bottles of water for $1 each. Sienna, the owner of the shop, needs to earn at least $100 by the end of the day. Write a linear inequality that describes the number of sandwiches and the number of water bottles that could be sold to reach their $100 goal. So if you notice, we have to decide what x and y are. I have two things that we're selling. So sandwiches and bottles of water. I know the prices for each, but I don't know how many are sold. So x is going to be the number of sandwiches sold. And our y is going to be the number of water bottles sold. So we know that for our inequality, each sandwich is $5. So we have 5x, and we're also selling water bottles for $1. So plus 1y. And because I'm looking at this word at least $100, at least is going to be the inequality greater than or equal to, because I want $100 or more. So finish graphing the inequality by shading the correct side of the boundary line. So because it's greater than or equal to, I want to shade above the boundary line. And it's a solid line because it's greater than or equal to. Name two different combinations of sandwiches and water bottles Sienna can sell to reach his $100 goal. So there's many things that we can select from here. I can choose something exactly on the line. So I can choose 10 sandwiches and 50 water bottles, for example, or I can choose maybe 20 sandwiches and 75 water bottles. These are just two examples of combinations that you can select. Good luck on the assignment tomorrow, and ask your teacher for questions. Have a great day.